Awesome. Good morning. Good morning. Welcome to the final day of AFOSR Spring Review. My name is John Schmisseur, and I'll be emceeing today's events. I'm the division chief for the, the Energy, Propulsion, and Power department here at AFOSR. I'm really excited to see all three of you who finally made it through the week and are here today. As for those of you who are watching, we'll watch this later on recorded, we've had a rough week. Monday was canceled. We moved everything to the right. I think my entire department was planning to take today off after our SAB review last week and then spring review this week. So we're limping into Friday. But I think we've got a number of strong presentations today, and we're excited to show you some of the accomplishments and advancements that have come out of our department over the last year. The subtitle of my talk today is Challenges and Opportunities in Air Force Energy Efficiency. And I would note that what we're really set up to do is to provide scientific innovation and discovery to turn those scientific challenges into some type of asymmetric opportunity for the warfighter. And that's what we keep in mind as we try and do world-class science. So let's go ahead and, I think I'm driving here. Maybe I'm not. So maybe I can say next. Oh, I got to turn it on.
On the side?
Yeah. There we go. Is it all right? You all mind if I walk around a little bit?
Go for it.
Perfect. There have been a lot of studies over the last few years that address energy efficiency as something that's important to the Air Force. Whether that's the National Aeronautics R&D Plan, the Energy Horizon study coming out of the Air Force Chief Scientist's Office, or a document a few years ago from the Air Force Scientific Advisory Board, the theme of we need to figure out how to do more with less and be efficient in the way we expend our resources has been a consistent one throughout a number of our major strategic studies and plans. When you look at the metrics associated with that, I think things become even more clear. About half of the DoD fuel consumption is associated with aviation fuel use by the Air Force. And one of the congressional reports indicated that when you look at the actual cost of delivering a gallon of fuel via air-to-air refueling, we're looking at $35 to $40 per gallon. In fact, I heard someplace that for a Special Forces forward fire base, that may be $100 per gallon actual cost to put energy on site for some useful purpose there. I was surprised when I saw some of the reports that have come out that said the estimated cost for the Joint Strike Fighter was going to be $32,000 per hour just to operate the system. And then just earlier this week I saw on an AIAA News report that in fact that's about the same amount as the U-2 and the Global Hawk costs $24,000 per hour to operate. So when you think about what we expend to have an operational capability in place per hour, I think there are opportunities we have at a system level to try and figure out how do we do things more efficiently. Our department is very well set up to try and address that in the long term. So we talk about the objectives of the department down here. I think that's a little vague. Let's be more specific. Our department is set up to look at multidisciplinary science in an integrated team fashion to try and figure out how to get the greatest return on an energy or financial investment for the Air Force in terms of specific capability. How do we get the most, quote, bang for the buck out of some type of Air Force system? And we're going to do that through innovative world-leading science. We've got a great team, and they're shown up here. We span the full spectrum of energy-related science, everything from Mike Berman's portfolio at fundamental molecular dynamics and chemistry, to cellular biology, to the system level and component phenomena that takes place in the continuum. We have the full range here, and we've got a great team of program officers. I was thinking as I was getting ready to come up here, between Mike, Meetot, and I, we probably have 60 spring reviews between the three of us. But then if you look at Chiping and Pat and Jennifer, there's probably 4 between them. So we have a bimodal distribution. We've got a lot of very experienced program managers. We've got a lot of young guns who are bringing some energy and excitement into the portfolio. We have a great team, and we focus on the full spectrum. There are a number of things, as we try and have an influence on where the Air Force is going in the future, we have really 2 major things in the department: energy storage and delivery, and energy conversion and utilization. And the presentations here today will be addressing those kind of broad themes. One of the key things we do is we have an extensive network of partners that we work with on a global scale. Many of them are located here in the DC area, and the ability for us to go and meet with them over lunch conveniently, to run across the street and talk with guys from DARPA, or upstairs talk with guys at ONR or NSF, that's a tremendous thing. But also at a global level, we're connected with a variety of agencies that fund science. So one of our key tenets is that we work with our global partners to try and implement our vision, again, at an international level. So there are a couple things that you'll hear this week. And the next couple charts are taken out of a presentation that I was able to give in January to a group of warfighters, a mobile military power summit. And I thought I'd tell you why folks found these things interesting. So out of Mike Berman's portfolio, we're going to hear, and I think Michael mentioned in his talk, about new self-assembled catalysts that improve the efficiency of methane combustion. Michael will get into the details of that, but the thing is, they've been able to reduce the temperature for the burning of methane to about 400 degrees Celsius. That's, we think, the lowest ever. That has tremendous implications for being able to have portable power someplace else. You know, turbines weigh something, but by reducing the temperature for combustion, we can do more efficient combustion, lighter turbine engines, make power available in more austere places. Pat Bradshaw's portfolio has some work in it that's very interesting. This is artificial photosynthesis. And the guys we talked to in January, the warfighters, were very interested when I said, you know, in the future, we may be able to power one of your forward fire bases with a couple of these devices in a bucket of water. We're going to drop one of these things in with sunlight, water, and one of these catalytic surface patches. We'll be able to separate oxygen and hydrogen and give you some type of remote fuel source, and again, in a very austere location. They were very interested in that future technology. And then going to the complete other side of the spectrum, Dr. Jennifer Jordan has a new initiative within our group that kind of ties together the interests of the entire department. We're going to be looking at dynamic reacting interfaces and the fact that whether you're looking at hypersonic ablation systems, structural energetics, solid rocket motors, warheads, there's a constant theme of how does a reacting material interface with an extreme environment, and the actual material interface between that, a coupled response between that non-equilibrium environment and the reacting interface. There's a lot of fundamental science there that we think if we unlock the critical phenomena that's going on there and be able to model that better, then there's a tremendous broad impact we can have across a number of systems that are of interest to the Air Force. So I'm going to leave it at that. I'm very excited about the presentation we're going to have from our program officers today. We have a couple minutes left of my talk. I wanted to give an acknowledgement to the folks in the back, the command headquarters, that are actually facilitating our streaming of the video today, and also tweeting and making sure that we have a presence in social media. I think that team's been tremendous in helping us raise awareness, and many of you are seeing this presentation because you're going to watch it on Ustream later on, either live or recorded sense. So we're trying to get a little more tech savvy and have a greater awareness of the AFOSR, and we really appreciate that. We have a whole team that actually drives that. So we want to say thank you to them. They coached me on how to be more relevant and on top of these things. You know, a couple years ago, we actually got them to tweet that I was the Charlie Sheen of aerothermodynamics at the time when Charlie was in the news. They're trying to get us more up to date and some things now. So I had some coaching on this, and hopefully they'll do this correctly. But welcome to hashtag AFOSR, hashtag Spring Review, hashtag we're the national leader in basic science, hashtag we are the Energy Power Propulsion Sciences Directorate, hashtag also known as RTE, and we're looking forward to a great day. So thanks again, and I'll now introduce our first speaker. So I guess we're going to do a mic